Hello guys, okay, today we're gonna solve a medium problem that launches binary subsequence less than or equal to k. You're given a binary string x, okay, and a positive integers k. Return the length. Remember, we need to return the length of the largest subsequences of x that makes up a binary number less than or equal to k. All right, binary number. I mean, we convert from binary representation to decimal. Okay, note the subsequences can contain leading zeros. Also, with this clue, we can see that as much, as most, like we need to ask as much a zero at the first as possible because it's not change, it's not affect our final value. It just increase our, just need to have increase our length of the subsequence. So, so the optimal way is to keep zero leading zero. If this string considered to be equal to zero, okay, this is the edge case when we got this edge case. Uh, like for example, when a case equal to like hmm, I think this case will not happen. Let me see. All right, if the worst case edge contain on one, and case is a number, like the small number is one or maybe two, then there's only a way. Like the two you can achieve the one, right? And the one you can achieve the one too. So this can never happen. Subsequences is a string that can be derived from another string by deleting some unknown characters without changing the order. Okay, that's mean from the original string S, we need to delete some characters, maybe some, maybe no characters, and we need to keep the original order of the remaining characters. All right. So let's take a first example. 1 0 1 0 0 1 0 1 0 and 5. 5 mean this right? 1 1 0 1. And you can see, you can compare this, and you can see this already less than the the last three characters of the original string n, because later we don't need to erase something from this, and we only need to remove the first, I mean the one character, this in this, remove it to keep on the zero, because it's not affect our final value. So we're gonna got 0 0 0 1 0 as the result here, and its answer is 5, the length is 5, right? mm. Let's take another harder example, this, and we're gonna find something like this. All right, you can see this larger, so we need to, we need to affect this, we need to delete some characters to make it smaller. And the best way, uh, I think we can delete this, make it become zero. And there's another way, like you can make it become this value, but if to get this value, that means we change the first two elements, that's it 1 0, from 1 1 to 1 0. That is exactly when become this, it must be passed through this state, that is 0 1 1. Then after that you can delete this, and make it become this, and maybe in the future, in the left side, the one count, and it become 1 0 1 at this. So to achieve the state 1 0 1, you must do at least two step, while to make it become 1 0 0, you need to make at least one step. So you can see the optimal, this is more optimal than the way we did to. So the optimal way is to just change the first, I mean the first characters in the right side of the right side, that's sharing the same width, same size of the k in binary representation. All right, so understand what I say? That I'm saying, um, we keep trying to delete the one at the beginning of the last, the first circuit, until you got a zero. All right, get zero. So after that, maybe you got a zero like this. Huh? So the remaining task you should delete on the one to keep on the zero. So the solution here is very simple. I gonna calculate the last the case. You need to calculate the size of the k first. I know. L maybe just a lot to k plus one. For example, if k is like 5, you can see 5, 4, log 2. I mean log 2 like 5 is return scale is gonna become 2 plus 1 is 3. It's 4. How about 4? 4 is like 1 and plus 1 is 2. Log 2 1 is like 0. But actually plus 1 is gonna become 1. Alright. This is the fast way to calculate the length in the binary representation of k. And uh, um, hmm, okay, make sure if L like already less than the sign S, so gonna return the S sign for sure, right? Because the length is larger, so it must be larger than the original string, but just return the original string. Now you need to calculate the binary representation of the you mean okay, for example, you got a binary string like this, gonna become like you can Google it and find the way to convert from binary representation to decimal. And this is all right. And as I say in my solution, here's the first value is the one we need to change. Delete. So, so my solution here is to um, first on the check if it's larger or smaller than the k. If it's smaller, so we already need to remove all the one. But it's larger, so we need to find the nearest zero. Find the nearest zero, and remove like all of that one. Oh, wait a minute. It seems like we only need to delete on the one, including this value. Okay, very simple. Right. Check first. Let's calculate. It's maybe largest than. It's maybe large, so I could use one here from the sign sk to sign. Let me see. This 1, 2, 3, 4, 5, 6, 7, and the length is 7. And case here is like, I mean, not k is L. L is like 3, so 3 is 4 from here. Alright, got it. That's one, right? Got the value here if the values like less than or equal to key. Oh, sorry. If one is less than key, so we're gonna delete on the 0, including this. First we need to count on the 0 and the 1 first. It's Latin, so we need to increase one more. I mean, including this value. Yes, is and sign. This is, let me see. Okay, let's test my case. All right. Okay, that's 9 day. I don't know. Don't look like my memory is not good. And how can we optimize this? I gonna use the okay here. Uh, we can optimize by instead of instead of kilo one, we can use exotic to remove the van, but it's require little complex here. So I think this is okay. It's enough. Mhm. Let's see. Let's check. Oh, you can see it's really good. Oh, it's really good. This solution is really good. But actually, it's used the same size with me. By the way, for example, use in, it might be wrong. Um, oh, it's still good. But it even like require more memory, so this is so arbitrary. I have a rule about this, but it's okay. Oh, this solution really good too, but I prefer this one. Okay, it's very simple. Have a nice day.